Welcome. In this lecture, I want to go through the existential quantifier, which is like there exists. And some of the ways that this can show up and how you prove things. So there exists, so this symbol here means, so what it means is there exists. Okay, so for example, we could have, as like a first example, you could write a statement like, there exists an x in the integers such that, so we use st a lot for such that, I'll put that there in addition to everything else, so such that x squared plus 16 equals 25, okay? And what this statement means, to kind of parse it, is, so this means there exists an integer, x, so that x squared plus 16 equals 25. Okay, so this is what it means kind of symbolically. When you see that, it's just, you can just directly translate it as there exists. And then it's important to know kind of how do you prove or disprove, like when you see these symbols, like if there's a there exists statement, how do you prove that it holds or prove that it does not hold. Okay, so proving and disproving. Okay, so to prove a there exists statement, so to prove one of these, we call it a there exists statement. There's kind of two steps, okay? So the first one is to state an example. An example, satisfying the properties, and then show that this example does indeed, the example works. i.e., like that it satisfies all the desired properties. So when I say like the example works, it would mean like, for example, here you have an x that satisfies this portion. Okay, so i.e. that it actually satisfies all the desired properties. Okay, and then the key thing here is that do not show in your final product proof how you found it. So do not show in your final product proof how you found it. Okay. I can actually kind of write that on the next line. So do not actually show how you found it. That's kind of like your private scratch work, okay? So how you found it. Right. So you will need to find the example, possibly. And a lot of times that involves working backwards. But you don't show that in your proof. That's not part of the justification. That's like, and I know how this can get confusing, because I know that up until a certain portion of your life, you're told to always show your work as if this is how you justify your answer. But we don't want to see your work at some point. It becomes, we no longer want to see your work. What we want to see is that your outcome actually does what it says it's going to do. Okay? And this is something that kind of, you know, it's a common mistake to actually include stuff that isn't actually justifying the statement, and we just want to see a justification of the statement. Okay, and so how do you do it? This is a two-step process. You state what your example is, and then you show it is actually an example of what it's supposed to be, so that, like, for here, you would want to verify that your answer actually satisfied x squared plus 16 equals 25. Okay, so that's for to prove. Now, if I want to disprove, so over here we can do to disprove a there exists statement. A there exists statement. Okay, so what do we do to disprove a there exists statement? So here you need to show that no example satisfies all the properties in this statement. So to disprove, you need to show that no example satisfies all the properties in the statement. And that's actually a hard thing to do, but there's kind of, there's a methodology for that, that no example satisfies all properties in the statement. And so often the way to do that, so we have a trick, a mathematical trick, which is to use proof by contradiction, which is say, suppose there is an example that satisfies all these properties. Then this would happen, this would happen, this would happen, and then we get something that's impossible. So there must not have been an example. Okay, so sometimes for this we use a proof by contradiction. So use a proof by contradiction for this. And that's it's a style of proof, or as I said, you suppose for the sake of contradiction that you have this, and then dot, 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 dot. Okay, so there exists statements. They show up all over the place, and we're going to talk about that more in the future lectures, that they can be hidden and so on. But it's good to know how you're going to be asked to prove that there exists statements sometimes. So it's good to know it's like, this is the procedure. Don't show us your work, but show us that what you have actually satisfies what it's supposed to. And then to disprove it is often proof by contradiction, and which is a very useful trick because you can't go through all the examples one by one and be like, nope, this one doesn't work, this one doesn't work, this one doesn't work, when there's probably infinitely many. Okay, so I hope that was a little helpful and made some sense, and I will see you in the next lecture.